Let's talk about polynomials. What does polynomial mean? Well, it's a Greek word. Has two parts. In Greek, poly means many, and nomial means number. Many numbers. Okay, I'm done. I'll sit down. Nope. So a polynomial is what we call a mathematical expression that has numbers and variables, and there's really only one rule. All of the exponents on variables have to be whole numbers. 0, 1, 2, 3, and so on. So x to the 400th is a polynomial. But x to the negative 2 is not. X to the 1.3 is not. X to the 5/4 is not. Okay? So we classify polynomials according to degree and number of terms. Number of terms is just a way for us to distinguish long, short, and small polynomials. Degree is actually more important because it talks about the shape of a particular graph, and we'll get into that a lot in this class. So the number of terms is just how many different multiplications are there separated using addition or subtraction. How many terms are there in number 1? 1. Negative 10x is just a multiplication. That is a single term. How many terms are there in 2? 2. What about 3? 3 doesn't have any variables. Is that okay? The number 7 is technically a polynomial because it's 7x to the 0. All right? So, number 9 would have 5 terms and so on. Degree has to do with the exponents. The degree is either the largest exponent when there's a single variable, you know, like it's all x's, then you just pick the biggest exponent. But if the terms have multiple variables, it's actually the sum of the variables, of the exponents of the variables. So in this case, we don't have to worry about it because every expression here is written in one variable. But if I had 5m to the 4th, n to the 6th, the degree is actually 10 because it's the sum of 4 and 6. Does that make sense? Now, that's for more advanced math. You're not going to see that here, but maybe later on you will. Okay, so what do we call a polynomial with one term? Monomial, 2 terms. Binomial, these are Latin prefixes. 3 terms. Trinomial, more than that. We would probably say a 4-term polynomial. Technically, you could do quartic and quintic and sextic and heptic and septic and whatever you wanted. But anything bigger than 3, you can just write 4 terms, and I'll be happy. Happier than I am today. Okay, so this would be a monomial. Monomial with a degree equal to 1. And then I'll leave you the rest of those. Okay? Number 9. Think critically. Why is it impossible to have a linear trinomial with one variable? Okay, wait a minute. What does linear mean? Straight line. What sort of polynomials, what are the characteristics of a linear polynomial? What does it mean to have a linear polynomial? Okay, well, it says one variable. So what is an example of a linear polynomial in one variable? What's that? Well, I guess, yeah. I guess technically that is linear. What's another linear equation? Okay, I'm asking very bad questions. So let me help you out. 4x plus 3. What makes that linear? The graph of it is straight, but without graphing it, could I tell it's linear? How? Well, we can't say it doesn't have an exponent. More specifically, the degree is 1. So when we say degree equal to 1, that means that the largest exponent is 1. So is the equation y equals 5 linear? Kind of. The line is straight, right? So if I were to graph that, it would look like this. It's straight, but is the degree 1? No. So it does graph a straight line, but because there's no x to the first, it's technically not a linear equation. So that, I mean, that's kind of a gray area in mathematics, but whatever. So why is it impossible to have a linear trinomial with one variable? It has to have 3 terms. Why can I not make this 3 terms? So what if I put x squared? Is that okay? It's no longer linear, right? So that can't happen. Well, what if I wrote plus 4? Now it's a trinomial. Ah, and that's the key. We always simplify before we name. So if you just have a big mess, you can't name it until it's been simplified. And that's kind of the key of that question. Anytime you simplify a linear trinomial with one variable, it will turn into at least a binomial or maybe a monomial. Okay? All right, moving on. Number 10. How do we add binomials together? We match up the variables and the degrees, which make like terms, and we combine them together. So does 4m to the 4th have a like term? M to the 4th. Now, they're not in the same order. Does that matter? No. In a polynomial, you can change the order of the terms as long as the sign goes with it. Okay, the terms of a polynomial commute. A lot of people call it the commutative property, like it lives in a commune or something. No, it's the commutative property because it commutes, it travels. So you can reorder them any way you want. Well, if I reorder them, is there a best order? Is there a way we can all choose where we all get the same order? What is the order that mathematicians prefer? Oop, try again. Big to small. And the reason we do that, so here we would want to do the 4th power first. So 4m to the 4th plus m to the 4th is 5m to the 4th. And then negative m squared plus 5m squared is plus 4m squared. Now the reason we care, descending order, that first term in a polynomial tells us more than anything else in the polynomial. And here's what I mean. If I have a polynomial of degree 0, okay, it's what we call a constant graph. It never changes. It never varies. So it would look something like this. Now that could move up and down, but it will be a horizontal line forever. Okay, if I have something of degree equaling 1, it's going to be some slanted line. It will either slant up or it will slant down. We're not sure. All of them, right? So a degree 2, do you guys remember what those look like? Quadratic equations? They're parabolas. They look like this. What does a degree 3 look like? It looks like this. And actually, if you graph it, the degree tells you how many possible roots it could have. So a cubic equation has the potential to hit the x-axis 3 times. Does that make sense? Does it have to hit 3 times? No. In fact, a parabola could miss entirely. Or a x to the 3rd equation could only hit once. So the degree of the parabola dictates the degree of the polynomial dictates the shape of the graph. So an x to the fourth would look something like this. It could hit 1, 2, 3, 4 times. And we're going to be going a lot more in depth with that than you've ever been before. So degree is really important in this class, which is why we always put the largest exponent first, and then we just go descending from there on. Okay, what about subtraction? How do you subtract two polynomials? Does 5x have a match? What is its match? So 5x and 4x make 9x, right? Right, it's 5x minus 4x, which is actually x. But I probably want to put this one first. X to the fourth minus 3x is negative 2x to the fourth. Okay? What happens if you subtract a negative? So let's do, what if I had 6 minus negative 4? What is that? Does anybody ever explain to you why? Don't say the teacher told me so. Or go ahead, and then I will go further than that. Why if you subtract a negative, does it make a positive? That's a really good way to say it, right? So think of a negative as a change in direction. So if I'm walking, and all of a sudden I do a negative, I change directions. Well, what if you're already walking backwards, and you change directions? Then you'll be going forward. That's a good way to explain it. Here's kind of a fun one. Let's say I was really rich, and I had $6 in the bank. Okay? And I went to Brittany, and I said, Brittany, I am going to write you a check for $4. Does this sound like a good deal? So, Brittany goes and cashes the check. What happens to my bank account? I now have $2. Boy, I haven't seen $2 in like 10 years. Okay, well, I have a fantastic checkbook. Your checkbooks, which checkbooks don't even really exist anymore. I write one check a month. Everything else is electronic. It's nice. So what if I had a checkbook, and so here's my checkbook, and over here in the box, all checkbooks have a dollar sign in the box, right? What if mine had a negative dollar sign in it? So I would take my $6 and I would subtract the value of negative 4. So I go to Brittany and I say, here's a check for $4. And she cashes it, and what happens? Her account dumps into my account, and I now have 10. It's like writing a bill, right? You know, giving somebody a bill. So if you subtract a negative amount, you're actually gaining money. And really, this check just said 6 minus positive 4, right? Which would deduct from my bank account. But if you subtract a negative, that's the same as adding. So there are lots of ways to think about this. Those are a couple. Okay. So number 12. What if we look, we have a trinomial and a trinomial, and the terms don't match up? What do you do? You just leave them and you write them in the correct order. So does the third exponent, or the x to the third, have a match? No, so you just write it down. Does the x squared have a match? Yes, so you combine them and write them down. Does the x have a match? No, so you write it down. Does the number, what do we call just the numbers at the end? They're called constants. Why are they called constants? They don't have variables, which means they don't vary. Right? If they don't vary, they must be constant. So those numbers at the end are constants. All right, turn the page. Multiplying. How do we multiply two binomials? You could say FOIL, but FOIL only works if they're binomials, if they're both binomials, the first, outside, inside, last. One way to do it is to use the distribution. This one times those two, and this one times those two. The one that you can use if you want, but you need to understand it to do something we're going to do later, is the multiply box. You put one polynomial on one side, and you put the other polynomial on the other, and then each square represents the product of the intersection. So that top left box is the product of 2n and n, which is 2n squared. The top right box is the product of 2n and negative 2, which is negative 4n. The bottom left box would be 3n and minus 6. Now what do I do? Combine like terms. Do I have any like terms? Yes. So 2n squared, no like terms. Those two n's create negative n minus 6. Now this box also works for larger polynomials, and I don't care if you use it, but you have to know how it works, because something we're going to do later, when I learned it the hard way, and since then I've learned a much easier way, and it's done using the box. It makes your life so much easier. Okay, so let's look at, let's do number 21. So in this case, I'm going to make a 3 by 3 box. X squared, 2x, minus 8, minus x squared, plus 3x, minus 5. So now each square, again, is the product of the intersection. Product meaning the answer to a multiplication problem. So what's this first box going to be? Negative x to the 4th. Is everybody okay with that? And then here I would get 3x to the 3rd. And here, minus 5x squared. And there. Negative 2x to the 3rd. And here, be 6x squared. And then negative 10x, 8x squared, minus 24x, minus, or plus 40. The nice thing about using the multiplication box is it's a lot easier to keep things organized, and it's easy to tell if you've skipped anything, because the box would be empty. Did I mess up? Oh. So this is negative. So that would be plus, minus, plus. How did I ever graduate from college? Okay, so do you notice anything about the like terms? They're in diagonals. Do you see that? The top left and the bottom right don't have any matches, but this diagonal here is nothing but x to the 3rds. This diagonal here is all x squareds, and this diagonal is all x's. Will that always happen? Okay, they've got to be in the right order. That's important. Not necessarily. Well, what do you mean by not like terms? Can you guys think of a time when the diagonals won't match? Because that's going to be really important. That could do it. Hopefully we won't have to do that much, but that could work. What if I had a binomial and a trinomial? Will the diagonals line up? So let's say So I had a binomial and a trinomial. So let's say this is x, that's x, and this is x squared. That's going to be x to the thirds. Are those both going to be x squareds? Well, this would be an x term, and this would be a constant, and that would be a constant. So x squared, yes. Will those both be x's? Yes. And then this one will be a constant. So that's not a case when they don't line up. But there is a pretty common case where the diagonals don't match. Figure it out, Ty? Said when they're not like terms, and you're kind of onto something. Anybody think of one where the diagonals won't match? Do you see what he's saying? So let me back up. Oops, too far. So let me make this box a little bit bigger. So Coulter said, let's do x to the fourth, x squared, and x. And let's do this one, x squared, x, and constant. Okay? So this would be x to the sixth, x to the fourth, x to the third, x to the fifth, x to the third, x squared, x to the fourth, x squared, and x. Why don't they match? So you'll see this doesn't match, and the last one happens to match. Why is that? What is it about those two polynomials that made them not match? Again, I'm trying not to waste your time. This is actually really important. Yes, that's exactly why. We skipped. I didn't need that. I didn't want that one anyways. We skipped an x to the third term. If that x to the third term was there in zero form, we would add a column in there, and it would be 0x to the fifth, 0x to the fourth, and 0x to the third. Now do they line up? Yeah. This one's blank, but the fifths line up, the fourths line up, and the thirds line up. Okay, now you don't have to worry about that today, but we're going to reach something where eventually you need to check, are there any missing terms? And if there are, you need to represent them with either a blank row or a blank column. Okay, so back to this. We can combine like terms, negative x to the fourth, that takes care of this. 3 and 2 makes 5x to the third. Negative 5, negative 6, and 8. So negative 11 plus 8, negative 3. Is that what you guys got? And then negative 24 and 10. So negative 14x plus 40. So what you got? Okay. This is your assignment today. When you go home, if you want to look up the answers, great. But you must show your work. If you don't show your work, we will give you no zeros and a free smile. We'll give you no points, which is a 0, and a smile. Okay, good luck.